Okay, so welcome everybody to this talk, and this is not deep dive, because I did the deep dive talk yesterday in Germany, but it was 50 minutes long, so now I only have 30 minutes, so it's just a regular dive, so not the deep one. Okay, so this is the content I'm going to cover today, but before we go into that, here's a nice tip from my, I used to be Microsoft MVP, now I'm just an employee. So I used to be part of MVP community, and this is my fellow MVP from Finland, where I also come from, and he said that he has a new strategy. So whenever he's sharing the slides, he's putting the worst picture of him. So when they see him live, they are like, okay, he doesn't look that bad. And this is like his picture. So, my name is Dr. Nestori Syynimaa, also known as Dr. Azure AD, and I work for Microsoft Threat Intelligence Center. And I have like two jobs, basically. So one is that I try to find vulnerabilities before the bad guys do. And the second one is like I want to educate people, and that's why I'm here now. So I'm going to tell about what kind of token protection stuff we have in Entra ID and what they actually protect against and what not. I'm also author of AAD Internals Toolkit. Who have used that? Okay, quite a couple. And I have some stickers, so if you catch me up after the talk, I can give you one. Or maybe two. Okay, so let's start with token-based authentication attacks. And let's start with three basic concepts. So we have user, like you and me. We have a service provider, which in this case could be like Exchange Online. And then we have identity provider, and in this case it's Entra ID. So it's providing identity and access management services. And these all roles are involved in this token-based authentication, regardless of what you are using. And very short, like introduction, how cloud works. So if I, as a user, let's say I want to use Exchange Online with my Outlook client. So what happens first? I go to Entra ID, and I need to prove my identity. I'm going to tell Entra that, okay, I'm using Outlook client. I want to access Exchange Online, and this is my username and password, for instance. And you need to understand that Entra doesn't know anything about me. I have to tell everything. Entra doesn't know which client I'm using, or where I want to go, or who I am. I need to provide that information. And in this case, it'd be like username and password and other information, what is needed. Now, as an exchange for that information, Entra creates you an access token and a refresh token. And that token contains that information, that who I am, maybe which device I'm using, which IP address I used, and so on. And now with that access token, I can go to service provider, like Exchange Online, and say that, okay, I want to read my email. And again, the service provider doesn't know anything about me. So everything is in that access token. So that token kind of tells me who I am. Like a good example of the token is this. This proves who you are and allows you to access this conference. So once you have that, you are good to go. So why this is important is that hackers don't need to break in anymore. They just need to log in. So you don't need to break in from the door because you have this. You can just walk in. Okay? So that's kind of like idea here. So this is a report, our report, what is that called? Microsoft Digital Defense Report from 2024. And as it says that 99% of identity attacks are password-related attacks. There's also, it says phishing, very small, but phishing. Like Jani showed us earlier that how you can do the phishing stuff. But we have other kind of things. So what happens, like post-authentication, for instance. So we have this token theft. So after user have logged in, you somehow steal the token, and then you can be the user. No need to break in or anything else. And there are other things that you can do related to token-based authentication attacks. For instance, if you are like a state-sponsored threat actor, you may like compromise your infrastructure or ours infrastructure, and then steal, let's say, secrets that you need to use to create tokens. But we are not going to cover that today. Okay, and then I know here are guys from SpectreOps, so you have seen this quote quite many times. So basically, how I see this is that you as a defender, you need to understand all the ways to get to the end goal, not just the direct part or that part, but everything, because that's what attackers do. And I'm going to show a kind of graph to you in a minute. So, token theft attacks. So there are basically two flavors that I'm aware of. And the first one is what Yannick already showed us earlier, and that is like adversary in the middle attack. We call this also sometimes network-based attacks. So usually, user normally goes to Entra ID and logs in, but threat actors can do like phishing things. So they are sending you a link that looks like our URL, but it's not. So instead, it goes to EvilThings or whatever you are using. So you go there, EvilThings shows you our login page. You type in your username and password, maybe do the MFA without FIDO keys, and then what attackers get is like your access tokens, refresh tokens, and also like session cookie. And after that, they can just, log in because they have your tokens. I may show you a demo later on, but let's see. Okay, and the second flavor of token theft is that threat actors are like compromising your endpoint. Okay, and they can steal stuff from there. And now what you can steal from user's endpoint? The worst thing, or best, depending on who you are, is the keys that proves the identity of the device. But that's only possible if you don't have TPM. Who is using TPM? On servers. Okay, you should. But anyways, that's only possible if you don't have a TPM and you have local admin permissions. Then you can steal those keys. Otherwise, what you can steal, if you have only user permissions, is like ESDS cookie. That's like a single sign-on cookie for Entra. So if you have that, you can get access to any service as you. Then we have a thing called PRT cookie. I won't go into details, but that also allows you to get access to pretty much to anything. And then we have those tokens. There are different types of tokens. And what kind of tokens we have? Okay, we have different tokens. Again, the worst or best is the PRT or primary reference token, which proves the identity of you and the device. So if you have access to that, you can get access to anything in the cloud as the person whose endpoint that is. But that again requires that you don't have TPM and you have local admin permissions and you know users' username and password. But if you only have access to the user, you can get access to a thing called family of client IDs, a reference token, which is a subset of our first-party applications. So for instance, let's imagine that I got access, this family of FRT, or let's call it FART, if you will. So if you get that, you can exchange that to, access tokens to other clients who are in the same family. Because usually reference token only get access to one client, only one client, but this is a little bit more better. And finally, you have the access or ID token. And that is like most restricted one. So you have access to one resource using one client, and it's only valid for 1 hour typically. But it could be up to 28 hours, but I'll show it to you later. Okay, so here's the graph for that. That explains to you that what options you have to get that access token. So if we start from here, so do you have access to that endpoint? If no, then you need to use adversary in the middle kind of attacks. Then you will steal those tokens and use them. Then if you have like access to that endpoint, if you don't have admin permissions, then you can just steal those tokens that are in the browser, for instance. So for instance, if you leave your laptop open, when you go to pick a coffee, your coworker can come to your endpoint or laptop and just copy those tokens and then they can be you. So don't do that. If you have admin permissions, you can install malware and then again, you can steal tokens. Or in the worst case, you can steal secrets like the PRT and the session key. And if you have those, you can then acquire tokens. So you can go to Entra and ask, give me tokens. And then you can use those. So this is kind of like attack graph we currently have. And here's some MITRE attack techniques. You will have slides, I suppose. We will share the slides afterwards, so you can click on those links. Okay, so we have 3 token security best practices, and first one is conditional access and or conditional access policies. Who is using? Of course you are using, no need to raise your hand. And that ensures that, or they may ensure that tokens are only used from trusted devices or locations. Then we have a token binding. That's the industry term. We have a thing called token protection, which is the same. And purpose of that is to prevent token relay attacks from different devices than where those tokens were minted in the first place. Who is using this? Or who knows that you are using this? Because most of the applications are already using them automatically. And then the last one is continuous access evaluation. And that thing or feature is protecting the session. So, for instance, if I get an access token, that is CAE or let's say K, or Kai, I don't know how to pronounce that. Let's say K, compatible. If then what happens, well, let's go back. So usually, if you have the access token, that's valid for 1 hour. Okay? This K kind of token can be valid up to 28 hours. But why? Because if something happens on the back end, let's say that user resets password, the normal access token is still valid for that 1 hour, even though you reset your password after that was minted. But this K is also valid, but if you try to use that after password reset, the backend server like Exchange Online will say you that, okay, there was an event that you reset your password, so you need to log in again. So that's why the lifetime is longer, and that's kind of like why it's also a little bit safer. Okay, so let's jump into these technologies. So how CAP or conditional access policies work. So you, as a user, you go to Entra. Okay, this is Nestori. I'm using Outlook. I want to, connect to Exchange Online. So here they are evaluated. So for instance, it could be like you require that I need to use like compliant device. I need to come from trusted locations and so on. And after we are past that phase, I will get an access token, and then I can use that access token to, connect, in this case, to Exchange Online. Let me see. Yeah, so conditional access policies, they may protect you against adversary in the middle attack, and also to acquire tokens. By acquiring tokens, I mean that if threat actor is capable of like stealing your PRT, but they are coming from IP address that you don't trust, we can have a policy that blocks that. And also with adversary in the middle, like the example Jani showed earlier. So if we have this evil things going on, so if we are requiring users to use, to access only from compliant devices, that evil thing box is not compliant device. So it will block that. I can show it to you. But okay, why may? Because I have no idea how you configure your policies, so it's up to you. So it may work or not. Or do you want to see demos? No? Okay. Let's try. So there we go. So we have evil things. So I'm just going to copy the URL like this. And then I'm going to close that because I don't want that you see my password. Okay, and here we have a victim user. So let's use Chrome. Let's go there. And by the way, the URL, if you see, it's Microsoft 0 online. So I just replaced the O with 0. So for me, it looks like a legit. And now I'm just logging in normally. And what happens now is that now the attacker has my username and password and also like session cookies and access tokens and whatever is moving on between that. And now it like redirected me back to the microsoftonline.com. And I'm, as a user, okay, I can just type in, and I didn't understood what happened. So what can we do about this? So if we do or enable conditional access policy, require compliant device for Diego, who is our victim here. I just say like this. And now I just need to hope that the SLAs are working. And let's try again. And I give my password. Now it says that you can get here from there. So yeah, conditional access policy may block that if you just configure it properly. And let's move forward. There we go. So then to token protection. So this is a bit difficult subject because, well, let's try to walk this through. So first of all, it supports certain backend services like Exchange Online, SharePoint Online, and Teams. It requires that you have a client that is supported. So currently, Windows 10 machine, which is hybrid joined or registered, and that's now preview for Mac OS and iOS. And you also need to have like supported client. Quite recently, we made a decision that you don't need to have P2 anymore, so only P1 is enough, so it saves you a lot of money. And how you deploy this, that you use conditional access policies, so you can require that for me to be able to, let's say, use my Outlook client to connect to Exchange Online, it has to support token protection, or otherwise it doesn't connect. Now, what is token protection? So these are like from our web pages. So basically, the basic idea is that we try to prevent token replay attacks. I'll just skip these so you can read them afterwards. So how this works? So you have a user who is using Windows 10 or whatever, other device that is supported. And by the way, Windows Server 2019 and newer are also supported, so it's a good thing to know. Okay, I go to Entra, and when this token protection is used, the request to Entra is a little bit different than normally. So it's a thing called JSON Web Signature. So it's a kind of a file or request or whatever. So it contains the PRT or primary request token, also like which client ID you are using, which resource you want to use, and then that is signed with session key, which is required to, use the PRT. They are they go hand in hand. And now what comes back is access token and request token, but these are in an encrypted container. So JSON Web Encryption container, and it has access token, ID token, and request token. But they are encrypted with the session key. So even though that you are using, let's say, adversary in the middle attack, you can see that what is coming back, but you don't do anything with that because you don't have the session key. So this kind of protects you against that kind of attacks, right? But then when that JSON Web Encryption stuff comes to your endpoint, it automatically decrypts that, which means that those access tokens which are inside that encrypted container are now non-encrypted in your endpoint. And then you use that to access services. So this means that you are still open for malware. So if that's installed in your endpoint, even though that you are using this token protection, the threat actor can access those tokens which are in your endpoint, in memory or in browser. So again, what token protection does is that it prevents adversary-in-the-middle attacks. Well, it doesn't prevent the attacks, but threat actor doesn't do anything with those tokens because they can't encrypt those. Okay? Doesn't make any sense. Okay. Then to the last one, continuous access evaluation. Who has heard about this earlier? Like earlier than today? Yeah, okay. Good. So, it supports our main backend things, and there are some requirements that you need to have like a supported client. You can also, I learned this yesterday because someone asked after my talk, do you support like third-party application? I said, I don't know. But now I know that we do. So you can have your own client also to use this. And it requires Entra ID P1. And you don't deploy that anymore. Now you customize that. So with continuous access policies, you can say that, okay, I can enforce like very strict location-based thing. So it means that if you move out of the IP range, you will get blocked immediately. Otherwise, it's, let's say, more flexible. And you can also disable that. So I don't want to use that. So that's what you can do with that. So how this works. So you go and authenticate yourself, okay, all good. But in that request, because you need to remember that Entra doesn't know anything about you. It doesn't know, does your client support this KAI? So you need to tell that. And how you tell that? You add a claim to that request. So like username equals Nestori, and then XMS_CC equals CP1. That's capability 1, don't ask. And now when Entra gets that, it knows that, okay, well, it doesn't know. It thinks that the client supports that. Now what happens is that now you will get that access token and refresh token, but instead of the 1 hour validity, it's now valid up to 28 hours if the client really supports that. And it also have like that XMS_CC equals CP1. So that when you use that access token, then the Exchange Online, for instance, it knows that, okay, this client now supports this KAI. Now, then if happens something critical, like for instance, users, let's say, password is reset, Entra can tell Exchange Online that now password reset was done. Which means that if you try to use that token after that kind of event, Exchange Online says, okay, you need to re-authenticate because there happened something. And this is kind of like what makes it like a little bit more safer. Yeah. So this may protect you about the use of token. But it necessarily doesn't, but it may help you to protect that. So I think we have some time for demos. Oh yeah, let's watch this slide before that. So how threat actors can exploit this. So they can just go and request tokens and say that my client is capable. So give me a token that is valid for 28 hours. And if they are doing that, like, let's say from the user's endpoint, or you don't, like, require those restrictive, like, IP locations, location-based stuff, they may use that 24 hours, up to 28 hours outside your, like, endpoint, whereas normally it would be only, like, 1 hour. So that's kind of a little of challenge. And for that purpose, I created a query, so which you can use in log analytics, which shows you that if there have been any like a KAI kind of like a request. Now I'm very bad at KQL, and this doesn't like it only lists those requests or logins. And if you want to do some threat hunting, that's up to you. But I'm just trying to tell that there's a way that you can see if somebody's using that. Okay, so let's try to do a demo. So we have 5 minutes and 3 seconds. So if our SLA works, so this should also work. So what I'm doing here is now that I'm going to request 2 access tokens using my toolkit. So one with Kai claims. Okay. I don't know what that means. Context parameter is empty. Let's try again. Something is not valid. Let's just try to run the whole stuff here. That's nice. I have the conditional access policy. Because this is an attacker machine and I am not that compliant. So let's remove that. So, do not require the compliant device anymore. So our stuff is actually working. Okay, then we go back here. And let's try to run the script again. Oh, it may take some time. That's better. We have tokens. So, and what I'm going to do now is that I'm going to reset the user's password. And that may take some time, so let's do that. Okay, so read AAD int access token AT2, show date. And that's like a regular one. And that is valid for, what is that, 90 minutes or so? But the second one, we said that this would support that Kai. And now we can see that there's a claim, CP1. And when we go up here, we can see that the token is valid up, well, that 20 some hours, 24 hours or something like that. And now we reset the password. So if we try to access Teams with this K supported like access token, it works. And this may take the 5 minutes. So let's see. We have 2 minutes left. Well, let me come back to that after I finish the slide. So we don't have to wait for that. So kind of like a summary here is now that if you use these token security best practices, so what things are covered? So the adversary in the middle, it's pretty well covered with conditional access policies and token protection. The acquired token, so if threat actor is able to get your PRT, you can block that. A use of token with continuous access evaluation. Now, there is no mitigation with these token security best practices to mitigate this part, so if you have access to your endpoint. But there are other things that you can do, like so bring your own device of pathing, don't do that. So please only allow people to access your services using endpoints that you manage. So otherwise, it's not a good thing. So let's see how our demo goes. No. This one here. No. Demo effect, so our SLA is not working that well. Oh, yes. Now we see unauthorized. But if we use the normal one, it still works. So that's how the conditional access evaluation can protect you from stealing tokens. Okay, so I guess no questions. We have 32 seconds. So if you want to ask something, I will be around there. Okay, thank you.